Hello and welcome to Cashmatics. In this tutorial I'll cover how to differentiate using the quotient rule. I'll be telling you when and how to use it, and also how to deal with functions which at first glance don't appear to be quotients. I'll be doing plenty of examples, so work along with me and make notes as and when you need to. So grab yourselves a pen and some paper and let's get started. The first thing we need to understand is when we use the quotient rule. And if you look at this over here, if I've got y equals u over v, where u is some function of x and v is also some function of x. So this is your quotient, u divided by v. Okay, so the quotient means the division here. And the rule is dy by dx equals g of x, so that's the v, multiplied by f dash x. Okay, so that's the derivative of u. Take away f of x, which is u, multiplied by the derivative of g of x, which is the derivative of v, all divided by the g of x all squared. Now that's a bit of a mouthful and it doesn't exactly flow off the tongue, but that's the version that's given in a lot of formula books. Now the way I like to remember it, and the way I was taught to remember it, was this. If you've got u and the derivative is du by dx, and then you've got v and the derivative is dv by dx, then dy by dx would equal v du by dx, take away u dv by dx, all divided by v squared. And you can even make that a little bit more brief, and this is the way I tend to write it down: v du take away u dv all over v squared. And this version here has some kind of poetry to it, and it's much easier to remember. So v du take away u dv over v squared, and you've got to remember to have the v there to begin with and the v on the bottom, okay, or v squared on the bottom. And the reason for that is the order is crucial here. Because the quotient is a division and the order of division is important, the order of the rule over here is important as well. So please bear that in mind. Anyway, I'll go through some examples and you'll see how to use it. This first example is fairly straightforward. So just remember, the top function is your u, the bottom function is your v. Okay, so that's u and that's v. So u is equal to x, which means du. So when I write du with an apostrophe, you mean du by dx. That would equal 1. V is equal to 2x plus 5, and dv would equal 2. So that's the derivative of 2x plus 5. So therefore, dy by dx equals, okay, and I tend to just draw my line for my fraction first. Okay, v squared on the bottom, so that would be 2x plus 5 all squared. And then we write the v on the top first, so I'm just comparing everything with what I've got over here. So v squared is what I wrote first, so this, remember, this is v. And then I've got v I need to write, so 2x plus 5 multiplied by du, which is 1. And even though it's 1, I'm still going to include it. Take away u, which is x, and dv, which is 2. Right? And all I need to do then is just tidy it up. So the top becomes 2x plus 5, take away 2x, and the bottom is 2x plus 5 all squared, and the 2x's cancel each other out, leaving me with just 5 over 2x plus 5 squared. Right, next we have this example. So we've got u over here and v over here. So u is equal to sine x, so therefore du would equal cos x, and v is equal to e to the 2x, and dv would equal 2e to the 2x. Remember, e to the 2x is just going to be e to the 2x, but then I need to multiply by the derivative of 2x, which is 2. Okay, and if you need to go back and look at the chain rule questions that I've done in a different video. Anyway, let's put it all together. Dy by dx would equal v du, so e to the 2x du, which is cos x, take away u dv, which is sine x multiplied by 2e to the 2x, all over v squared, which would be e to the 2x squared. Okay, now let's see what we can do with this. Now the top and the bottom all have an e to the 2x in them. Okay, so that and that can cancel each other out. Okay, so I'll have cos x take away 2 sine x all over e to the 2x. Alright, let's take a look at this one. So this time, that one's my u, that one is v. So u equals ln x, and du would equal 1 over x. Remember, ln x differentiates to become 1 over x. V is equal to 2x plus 5, and dv would equal 2. So let's put it all together and see what we get. So dy by dx, oops, let's make a better x than that, equals v du, so 2x plus 5 multiplied by du, which is 1 over x, minus u dv, ln x multiplied by 2, all over v squared, which is 2x plus 5 all squared. Now, in order to tidy this up a little bit, what I could do, I could multiply the top and bottom by x. And by doing so, I can get rid of this x from here, and it might just make the whole thing look a little bit tidier. So if I was to do that, I'd end up with the first term at the top would become just 2x plus 5. The second term would become 2x ln x, and the bottom would become x brackets 2x plus 5 all squared. And I'm sure there's something else you could do with that, but the main point is, getting to the derivative. So yeah, that's that one. Right, now they're starting to get a little bit trickier. So again, that is my u, and that is v. So u is equal to sine squared x. So du equals, now remember, something squared becomes 2 times the something. So for example, x squared becomes 2x. So this becomes 2 sine x, but then I've got to remember to multiply by the derivative of sine x, which is cos x. Okay, and v is equal to ln of 2x. So dv would equal 1 over 2x multiplied by the derivative of 2x, which is 2. So those cancel each other out and leaves me with 1 over x. Now if you wanted to, you could also write this using sine 2x. Okay, so using the identity sine 2x equals 2 sine x cos x. If you know that identity, you could write it slightly differently. Right, okay, let's put it all together then. Dy by dx equals v, so ln 2x, du, which is sine 2x, minus u dv, so sine squared x multiplied by 1 over x, all over v squared, which would be ln of 2x all squared. Right, so let's see what we can do to tidy this up. So just like before, I can multiply the top and bottom by x, and that first term becomes x ln 2x sine 2x. Take away sine squared x, because 1 over x will cancel out with that x, all over ln of 2x. Let's correct that a little bit. All squared. Okay. Now it might be worth actually writing this in the original form, 2 sine x cos x, because then I could factorize out a sine x as well. Okay, but like I said, that's not the point of all this. The point of all this is being able to differentiate. Okay, and we'll do one more before we go into ones which don't actually look like a quotient. But we'll do this one first. Okay, so we've got u there, and that is v. So u is equal to x plus 3, which means du would equal 1, and v equals, now I'm going to write this as 2x plus 1 to the power a half. So dv would equal 1/2 2x plus 1 to the power minus a half multiplied by 2. Remember, I have to multiply by the derivative of what's inside the brackets. So that 2 and that 2 cancel each other out, and that gives me 2x plus 1 to the power minus a half. Right, now this is going to be a little bit tricky to put together, but let's just take our time. Dy by dx is equal to v du, so 2x plus 1 to the power a half multiplied by 1. Take away u dv, x plus 3 multiplied by 2x plus 1 to the power minus a half, all over v squared. Now if you think about it, v squared would just remove this square root sign, so that would be just 2x plus 1. And what I can do here is I can actually cancel out some 2x plus 1s because I've got them on the top as well as the bottom. So what I'd need to do is just subtract the powers. So I've got a half there and 1 here. So a half take away 1 is minus a half. So 2x plus 1 to the power minus a half. Remember this 1, we just don't need to write it. Take away x plus 3 times by 2x plus 1 to the power. Now minus a half take away 1 is minus 3 over 2. Now you could write it slightly differently if you wanted to by putting it in the denominator, but it's fine just as it is. Now here we have one which doesn't actually look like a quotient. So before I do anything with it, I'm going to rewrite it. So y is equal to tan x, which is actually sine x over cos x. Okay, and now it looks more like a quotient. So this here is my u, this here is v. So u is equal to sine x, which means du is equal to cos x, and v is equal to cos x, which means dv, sorry, that's meant to be a v, is equal to minus sine x. So let's put all that together. So y would equal v du, so cos x multiplied by another cos x, take away u dv, so sine x multiplied by minus sine x, all over v squared, which would be cos squared x. Now let's just see if we can tidy this up. The top becomes cos squared x plus sine squared x, and the bottom becomes, well, stays as cos squared x. Now remember the identity, sine squared x plus cos squared x is 1, so the top just becomes 1, so it's 1 over cos squared x, which is equal to sec squared x. So this is a good result because it's useful for differentiating and integrating, well, differentiating tan and integrating sec squared, and it's a standard result in the books, in the formula book, but sometimes in an exam you're asked to show how to get there, so make sure you can do this short little proof. Now we've got something very similar here for cot x. So what I suggest you do here is pause the video and see if you can rewrite it as a quotient, and then play the video and see if you got it right. Right, here we go. So y is equal to, so if sine x over cos x is tan, cos x over sine x is cot, so that'd be cos x over sine x. So there's u and there's v. So u equals cos x, which means du is equal to minus sine x. V is equal to sine x, which means dv is equal to cos x. So dy by dx is equal to v du, so sine x minus sine x, take away u dv, which is cos x, all over v squared, which is sine squared x. Okay, so what do I get here? I get minus sine squared x minus cos squared x. I'll do it in 2 stages. So minus sine squared x minus cos squared x, all over sine squared x. And then what I'm going to do here is I'm just going to factorize out of minus 1. So minus 1 sine squared x plus cos squared x over sine squared x. Okay, let's take it over here. So that there in the bracket, sine squared x plus cos squared x is 1, okay, which I told you about just earlier. Okay, so the top would just become minus 1, so it'd be minus 1 over sine squared x. Okay, and 1 over sine squared x is cosec squared x, so this would be minus cosec squared x. Right, okay, so that's, I think, 7 examples for you. Okay, I hope that's helped you to understand how to use the quotient rule. Just got to make sure you remember the top function is u, the bottom function is v, and then the rest, you just need to take your time and make sure you get all the signs in the right place, and you just take care with the algebra. And it is beneficial if you can remember this rule off by heart. So what I've got up there in green is the version I tend to remember, and if you use it enough times, it'll just be natural to you, and you'll just be able to do it without having to think about it too much. Anyway, I hope that's helped, and I'll see you next time. Goodbye for now.